Okay guys, so back to some of our videos. This is section 3.2 and you are taking your own notes today, and I am going to be checking them tomorrow, so let's just make sure that we do everything that I've been asking you about your notes. On the top, this is section 3.2, part 1, and also go ahead and put the date up there as well. We are still working with linear systems of equations like we were yesterday, okay? And to remind you, a system of linear equations is any equation in the form, and it's ax plus by equals c, or dx plus ey equals f. Well, one of the things I said to you yesterday about a system of linear equations, more in like our own words, is that it's two linear equations with two variables. In order for it to be a system, it has to be two equations, and in order for it to be a system as well, it has to have those two variables for us. Okay, so I'm going to give you a second to write that down, and we're going to keep going. All right, so yesterday we also learned that a solution to a system, and we should be looking right here, a solution of a system of linear equations is a coordinate point, an ordered pair. It's in the form x, y, okay? When we did them yesterday, we solved by graphing, and we kept finding a coordinate point. So let's look at an example from yesterday, okay? I'd like you to get your calculators out for me, and we're going to look at this particular example. Y equals 2x, and y equals 2x plus 4. It is a linear system of equations because it's two equations with two variables. Now, if I'm to graph these two, the first one, y equals 2x, and I did it right here, that means the y-intercept was 0 and the slope was 2. I'm going to go up 2 over 1, and I drew my line. The second equation, y equals negative 2x plus 4, my y-intercept is 4, my slope is negative 2, so I know that my line is falling. I'm going to go ahead and graph that. So I go up to my y-intercept of 4, I go down 2 to the right 1, plot my points, and graph them. All right, so yesterday what we did was we found, or we estimated, the point of intersection. So the solution to this particular system is 1, 2. It is the point of intersection of the two lines. That is the solution, okay? I also showed you how you could do this with your calculator. So if you'd like to verify it with your calculator right now, why don't you go ahead and do that, okay? Make sure you get that practice in. All right. I also told you that there were two other ways that you could solve a system that you've seen before. The one we're going to talk about today is the substitution method, okay? The substitution method means you're going to combine the two equations using substitution. So the first thing that you would do is you look at your two equations and you have to decide which variable you should solve for. My suggestion is to always solve for the variable that has a coefficient of 1. Do you notice that that x has a coefficient of 1? All right, so I'm going to solve for x in this equation, and I'm going to be as neat as I can. So if I solve for x, that means subtract 2y to the other side. And I'm going to rewrite my new equation over here. X equals 2 minus 2y. Okay? So step 1 is then to solve one of the equations for one of its variables. You can write the step down if you need to. All right. Then you're going to take that 2 minus 2y, that value you came up with for x, and you're going to substitute it into the other equation. So I'm going to take that and I'm going to plug it in for x in the other equation. So now my new equation would be 3 times 2 minus 2y. Notice I put it in parentheses. You're always, anytime you plug something into another equation, we want to put it in parentheses. Plus 4y equals negative 4. All right, so we are going to substitute the expression from step 1 into the other equation and solve for the variable. Well, it's nice now because everything is an equation in one variable, which you do know how to solve. the first thing we're going to do, distribute the 3. So we get 6 minus 6y plus 4y equals negative 4. Okay, we're going to keep solving, and we're going to combine our like terms. So we get 6 minus 2y equals negative 4. Keep going. We're going to subtract 6 to the other side. I get negative 2y equals negative 10. And then I'm going to divide both sides by negative 2. And I will get y equals 5 because the negatives will cancel. All right. However, that's only one value, and yesterday we learned that it has to be a coordinate point. So now we need to substitute the value from step 2, y, into the revised equation from step 1 and solve. Okay, so that gets kind of confusing. Basically what you do is you take your 5, you go back to that revised equation that we came up with, 2 minus 2y, and you put it in and solve for x. I'm going to do that over to the right. So I'm going to say x equals then 2 minus 2 times 5. X equals 2 minus 10, and then so x equals negative 8. Then I write my answer as a coordinate point, negative 8, comma 5, because our answer to a system of equations, our solution, is an ordered pair or coordinate point. So that, again, is where those two lines, if I were to graph them, it's going to be where they intersect. Okay? All right, now I want you to try. Okay, so what I'm going to do is I'm going to start it in a second. I want you to pause the video right here, try the example, and then turn it back on and see if you did it right. Okay? All right, so you should all be pausing. Yes, pausing. All right, so I'm going to solve for one of the variables. So I'm going to look for the one that has a coefficient of 1. I see that it does right here. Okay, but I'm going to actually solve for it, and I'm going to get x equals 1 minus 3y. I'm sorry, negative x equals. Well, we don't want to solve for negative x. We want it to be just plain old x. So I'm going to divide everything by negative 1. And that's going to give me x equals negative 1 plus 3y. Now, I don't like having negatives in the front of my expression, so I'm going to rewrite that as x equals 3y minus 1. All right. Some of you may have chose to bring the x to the side and the 1 over originally. Now I'm going to take that new x that I have, that revised x, I'm going to plug it into the other equation wherever there is an x. Anytime I plug it in, I put it in parentheses. Okay, I distribute my 4 to everything, and I get 12y minus 4 plus 6y equals 8. I'm going to keep going. Extend my page a little bit so you can see. Combine my like terms. 18y minus 4 equals 8. I'm going to add 4 to both sides, the opposite operation. So 18y equals 12. I'm going to divide by 18 on both sides, and I'm going to get y equals 2/3. Can we have a value that's a fraction? We sure can. So now I'm going to take that y that I just got, and I'm going to plug it in to the original revised equation to find x. So x equals 3 times 2/3 minus 1. Hopefully you're seeing that this is set up beautifully for you to cancel. 3's will cancel to 1, so I have x equals 2 minus 1, so x equals 1. All right, hopefully you guys got that example right. Let's move on. Yesterday we talked about 3 things that can happen with a system of equations, and these things are still going to apply. You could have one solution. One solution would mean you have one point of intersection. Okay, one point of intersection. Infinitely many would mean that the solutions, that the equations are the same line. And that means they intersect on every single point on the line. And then the last one is no solution. Okay, and you have to be careful with no solution. Remember, it just means there's no point of intersection. So if it's 2 lines that don't intersect, that means that the lines are going to be parallel. So it means that we have parallel lines. All right, so what I'd like us to do is like to look at examples of what happens with this. So let's look at this one. X minus 2y equals 3 and 2x minus 4y equals 7. So we are going to solve by substitution. So we're going to solve for the variable that has a coefficient of 1. So let's do that. So I'm gonna actually bring the 2y to the other side. I'm going to solve for x. Let me switch colors here. So I'm going to change this equation to x equals 3 plus 2y. I'm going to take that value, I'm going to plug it in for x into the other equation. So I have 2 times 3 plus 2y minus 4y equals 7. All right, I'll give you a second to catch up. I realize I did that kind of fast. Okay, then we distribute our 2. So we get 6 plus 4y minus 4y equals 7. Okay. We combine our like terms. Ooh. Well, that leaves me with 6 equals 7. Can we have 6 equaling 7? Does 6 equal 7? No. 6 does not equal 7. So this can't happen. This is no solution. Okay? No solution. So what does that mean? What does that tell me? It tells me that the lines are parallel. Okay, so just be careful that you understand this. If the solution gets you to, or if the answer gets you to 6 does not equal 7, it does mean no solution, but then I want you to state, therefore the lines are parallel. Okay? All right, one more. Let's look at the next one. What if? What if? Okay, so now this one's slightly different. We have to decide which variable to solve for. Always look for the one that has a coefficient of 1. So I'm going to actually solve for y this time, aren't I? All right. So I'm going to bring the 3x to the other side or bring the y to the other side and then bring the 4 over, and you will be left with y equals 3x minus 4. Now I know that I did that quick. I decided to bring the y to this side by adding it and then subtracting the 4 to this side, so then I didn't have to divide by -1. All right, now I'm going to take that y, I'm going to plug it in. I'm going to plug it in for anywhere there's a y in the other equation. So then we get negative 9x plus 3, parentheses. Again, we plug it in, we put it in parentheses. 3x minus 4 equals negative 12. All right, we distribute our 3. And we're going to get negative 9x plus 9x minus 12 equals minus 12. Combine the like terms. Again, these cancel, but ho! What's this? Negative 12 equals negative 12. Is that true? It is true. So it's not no solution, is it? This is a situation where this is a true statement, so it means that there are infinite solutions. And what did we say infinite solutions told me about the lines? It means it's the same line. What we like to say is we say that the lines coincide. Let me move that up. Coincide. Okay? And that really means they're right on top of each other. Okay? All right. So what should you have learned today about substitution? We should know that a systems of linear equations, when we solve it, it's a point of intersection. We should know that we have to have 2 equations with 2 variables in order for it to be a system of equations. Using substitution, you solve for the variable that has a coefficient of 1 if you can. That doesn't always work, but meaning there might not always be a variable that has a coefficient of 1. But substitution is a great thing to use when you do have one that's a coefficient of 1. You have to remember that there's 3 different solutions that we can have to these equations. That you could have 1 point of intersection, no points of intersection, or infinitely many points of intersection. So tomorrow when you come into class, we're going to practice this using substitution, and then we're going to look back at those real-life examples, those word problems with systems, writing our own equations and then solving them using substitution. Okay? All right, see you guys tomorrow. Bye.